Right now, beneath the streets of Naples, Italy, home to more than 3 million people, the ground is rising. Not slowly, not subtly. Since 2005, the Earth has lifted over 1 full meter. That's more than 3 feet of vertical movement beneath one of Europe's most densely populated cities. And the rate is accelerating. The cause? A supervolcano caldera called Campi Flegrei, 12 kilometers across, hidden in plain sight beneath the western suburbs in the glittering Bay of Pozzuoli. It doesn't look like a volcano. There's no mountain, no cone, but it's there, breathing. For decades, scientists believed they understood exactly what this meant. Rising ground equals rising magma, the classic warning sign. Fresh, molten rock pushing upward from the deep, preparing to erupt. But a new generation of studies has overturned that assumption completely. The real driver is something else, something harder to track, harder to predict, and in the eyes of many researchers, far more dangerous than the textbook scenario they'd been watching for. So if it's not magma rising beneath Naples, then what's actually lifting the city? To understand why scientists rewrote the playbook, we need to start with what changed and when. In late 2023 and early 2024, research teams at Italy's National Institute of Geophysics and Volcanology, INGV, published findings that fundamentally revised the cause of Campi Flegrei's ongoing unrest. Peer-reviewed studies analyzing seismic data, ground deformation, and gas emissions confirmed something unsettling. Magma is not actively intruding. Instead, the uplift in earthquake swarms are driven by pressurized hydrothermal fluids and volcanic gases, superheated water and gas trapped in fractured rock above the deeper magma reservoir. The data now shows the old model was wrong, and the new one introduces something far more frightening: unknowns. If the engine beneath Naples isn't the predictable rise of molten rock, the playbook for reading warning signs just went out the window. Before we go further, let me be clear about what this video will and won't tell you. This isn't a doomsday video. You won't hear me claim I know when something will happen. No one does. What I'll walk you through is the actual science, real numbers from INGV and Italian civil protection, the historical record, and the legitimate debate among volcanologists about what this unrest actually means. The title sounds scary because the reality is unsettling, but everything you're about to hear is backed by research, not hype. I'm not here to sensationalize. I'm here to give you the facts, the context you need, and the honest uncertainty that still exists. You can share this video without embarrassment. That's the promise. And because this affects real people in real places, I want to hear from you. Have you ever been to Naples or the towns around the Bay of Pozzuoli? Have you felt the small earthquakes there, or seen the Roman ruins that have risen and fallen with the ground over centuries? Tell me in the comments where you were and what you noticed. If you subscribe and tap the like button, it helps this video reach people who live in the shadow of Campi Flegrei, people who deserve to understand what's happening beneath them. This isn't just about algorithms. It's about getting real information to real communities. To understand why the absence of rising magma is so unnerving, you first need to know what Campi Flegrei has done before and how close we've come in living memory. Picture this. You're walking through the narrow streets of Naples. Colorful laundry hangs from balconies. The air smells of espresso and salt from the bay. Fishermen mend nets in the harbor of Pozzuoli, just as they have for centuries. You're standing inside a volcano, not on it, inside it. Campi Flegrei isn't a mountain, it's a caldera, a collapsed volcanic crater 12 kilometers across, hiding in plain sight beneath Naples' western suburbs in the shimmering Bay of Pozzuoli. Where you see busy streets and ancient Roman ruins, geologists see the floor of a sleeping giant. The Temple of Serapis stands as proof. These Roman marble columns have risen and fallen with the ground for 2,000 years, sometimes submerged beneath the waves, sometimes standing high and dry. The locals call it bradyseism, the breathing of the earth. But this thing has done more than breathe. 39,000 years ago, Campi Flegrei exploded with a force that may have changed the course of human evolution. The Campanian ignimbrite eruption shot ash across Europe, contributing to a volcanic winter that early human populations barely survived. 15,000 years later, it happened again. The Neapolitan yellow tuff eruption shaped the very bay you see today. Back then, empty wilderness. Now, one of Europe's most densely populated metropolitan areas, 3 million people living where nature once wrote its most violent chapters. The 1980s began quietly enough in Pozzuoli, the town at the caldera's heart. Residents noticed small things first: cracks appearing in walls, doors that suddenly wouldn't close properly. On the waterfront, familiar as an old friend, somehow looking different. Then the numbers started telling a story. Between 1982 and 1984, the ground rose nearly 2 meters. 6 feet of vertical lift beneath an entire town. Thousands of small earthquakes followed. At first, just rattling windows, then strong enough to crack foundations. The fear was immediate and primal. No one knew if this was the preamble to an eruption. Maria Costabile owned a small cafe near the harbor. She remembers the morning her kitchen floor cracked straight across. When the espresso machine tilted, she told reporters years later, that's when I knew something was really wrong. By 1983, the Italian authorities faced an impossible decision. Was this a failed eruption building toward disaster, or just the Caldera's ancient breathing? They chose caution. 40,000 people were evacuated from Pozzuoli's town center. The crisis made international headlines. Volcanologists descended from around the world. Emergency plans were drawn up for the evacuation of Naples itself. Then, nothing. No eruption. The ground stopped rising. It even subsided slightly. Slowly, carefully, people moved back to their homes. But the mystery remained. What had they just lived through? Scientists at the time reached for the simplest explanation. Magma had tried to rise from the deep reservoir and stalled. Fresh, molten rock pushing upward, stopped by overlying pressure or some blockage in the plumbing. It made perfect sense. It was clean, simple, and it fit the textbook model of how volcanoes work. That explanation, magma intrusion, became the dominant theory for Bradyseism. For decades, it's what everyone believed. The 2000s brought new unrest, but this time it was different, slower, steadier, relentless. By 2024, the ground had risen over 1 meter since 2005. Earthquake swarms intensified, hundreds per month at times, some reaching magnitude 4 or higher. But here's where the detective story takes a turn. The deep magma indicators that scientists expected to see, the kind that appear before major eruptions at volcanoes worldwide, simply weren't showing up. No large-scale magma movement at shallow depths. Gas emissions were high, yes, but the chemistry was wrong for fresh magma. Seismic tomography confirmed the magma reservoir was still there, deep, about 8 kilometers down, but it wasn't climbing. Dr. Stefano Carlino at INGV began asking the obvious question, if magma isn't pushing up, what is? The answer, when it came, changed everything. New models revealed the real engine, supercritical hydrothermal fluids, superheated water and volcanic gas trapped in the fractured rock layer above the magma, building pressure like a slow cooker with a stuck valve. That revelation, that the ground is rising not from molten rock, but from pressurized gas and fluid, changes everything. To understand why, we need to talk about what's actually happening down there. To understand what's really happening beneath Naples, you need to picture something that defies common sense about volcanoes. Deep below the caldera, 8 kilometers down, there sits a large magma chamber. Still hot, still active, but not moving. Think of it as a massive underground furnace, radiating heat upward through layers of fractured rock. That heat doesn't just disappear, it does something far more complex. Above the magma, in a zone 3 to 4 kilometers deep, there's water, lots of it. Ancient seawater trapped when the Mediterranean was higher. Groundwater that seeped down over millennia. Fluids squeezed directly from the magma itself. Under normal circumstances, water at that depth would just be hot water. But at temperatures of 300 to 400 degrees Celsius, hotter than your oven's maximum setting, and under the crushing pressure of 3 kilometers of rock, water becomes something else entirely. It becomes supercritical. Neither liquid nor steam, supercritical water has properties that seem impossible. It can dissolve massive amounts of gas, carbon dioxide, sulfur compounds, other volcanic gases rising from the magma below. It becomes a chemical cocktail under extreme pressure. Imagine a massive pressure cooker buried kilometers underground. The heat is constant, the lid is the fractured rock above, and the pressure just keeps building. But here's the crucial difference from your kitchen pressure cooker. The lid is cracked. The rock layers above Campi Flegrei are fractured from past eruptions, from the ongoing stress of the system itself. So this supercritical fluid doesn't just sit there. It migrates. It finds weaknesses. It pools in pockets. And as it accumulates, it pushes upward with enormous force. The volume of rock being displaced is staggering, comparable to injecting billions of liters of pressurized fluid underground. Every centimeter the ground rises represents unimaginable pressure transferred through solid stone. The energy involved is equally mind-bending. Each magnitude 4 earthquake releases energy equivalent to several tons of TNT. Over the years of ongoing unrest, the cumulative seismic energy is comparable to hundreds of conventional bombs going off beneath Naples. Yet from the surface, you'd never know. No glowing lava, no obvious mountain, no dramatic fountains of molten rock. Just slow, steady creeping and occasional shaking that most of the world ignores completely. This is what makes the hydrothermal mechanism so much harder to predict than traditional magma movement. When magma rises, it leaves clear fingerprints, distinct seismic signatures as rock fractures, predictable deformation patterns as the ground swells, chemical changes in gas emissions that volcanologists can track and model. Hydrothermal systems are chaotic. Pressure builds in one area, then vents through a fracture miles away. Fluids migrate unpredictably through the fractured rock. The system can release pressure gradually through small earthquakes or suddenly through larger swarms. Sometimes it vents harmlessly as gas through fumaroles, natural vents in the ground. Sometimes pressure just relocates. There's no simple countdown timer, no linear progression toward eruption. And the risks aren't just volcanic in the traditional sense. Phreatic explosions, steam-driven blasts, can happen with virtually no warning when pressurized fluids suddenly flash to steam. Think of a massive underground steam explosion, capable of hurling rocks and ash over a wide area. There's also structural destabilization. All that pressure, all that fluid migration can weaken the caldera rim itself. Parts of the system could collapse without any eruption at all. Most concerning to some researchers, the possibility that enough hydrothermal pressure could eventually fracture a pathway that the deep magma could exploit. The fluid pressure could, in theory, become the key that unlocks the door for magma to finally rise. The old model was predictable. Magma rises, pressure builds, eruption follows, or doesn't, and pressure releases harmlessly. This new model offers no such comfort. It's a system constantly in flux, constantly finding new equilibriums, constantly capable of surprise. So here's the question that should keep people awake at night. How many people are living on top of this pressurized, unstable system right now? When Campi Flegrei last erupted in 1538, a small event that built the cone of Monte Nuovo in just 1 week, only a few thousand people lived nearby. Today, more than 3 million people live within the immediate risk zone. Let's make this personal. If you've ever visited Naples, you've walked directly over this system. The neighborhoods of Rewrote, Bagnoli, and Posillipo, all built on the Caldera floor. The University of Naples campus where students attend classes, the San Paolo Stadium where Napoli plays to crowds of 50,000. The towns have names you might remember. Pozzuoli, where cruise ships dock and tourists explore the ancient Roman market called the Macellum, those same marble columns that have risen and fallen with the breathing earth for 2 millennia. Boccoli, with its underground Roman cisterns. Quarto, where families raise children in apartments overlooking the bay. Just offshore, the islands of Ischia and Procida, where visitors soak in thermal springs heated by the same system that's lifting the mainland. If you've taken the train from Naples to Sorrento, you've crossed the Caldera. If you've driven to Pompeii, you've skirted its eastern edge. This isn't some remote wilderness. This is one of Italy's most vibrant, densely populated regions. INGV's monitoring reports paint stark scenarios. Italian Civil Protection's risk assessments don't mince words. Even a moderate phreatic eruption, a steam-driven blast, could shower the area in scalding ash and volcanic debris. Infrastructure would crumble. The airport would close. Remember Iceland's Eyjafjallajökull in 2010? That relatively small eruption grounded air travel across Europe for weeks. Now imagine that disruption centered over one of the continent's busiest airspace corridors, with ash clouds drifting over Rome, over the heart of Mediterranean commerce. Economic analyses estimate tens of billions of euros in damage and displacement from even a modest event. But a larger magmatic eruption, if the hydrothermal instability eventually fractures a pathway for the deep magma to exploit, could be catastrophic on a regional scale. Not just Naples, not just Campania. The ripple effects would touch every corner of Europe. The contrast with 1538 is devastating. Modern Naples is a dense urban maze, narrow medieval streets that would become death traps in a panicked evacuation. High-rise apartment buildings constructed long before modern earthquake codes, housing elderly residents who couldn't flee quickly even if they wanted to. The evacuation routes themselves cross the very caldera they're meant to escape. The A56 ring road, the primary highway out of the region, runs directly over the most unstable ground. The rail lines to Rome pass through the heart of the risk zone. Moving 3 million people isn't just difficult, it's a logistical nightmare that would take days under the best circumstances. And here's the cruel irony. The better the monitoring becomes, the more we understand how little warning we might actually have. The old model gave false comfort. Rising magma meant months or years of increasingly obvious signals. Clear escalation, time to prepare. The hydrothermal model offers no such luxury. Phreatic explosions can happen in hours, structural collapses in days. The system's chaos means the difference between normal unrest and dangerous instability might only be visible in hindsight. Right now, as you watch this, the ground is rising a few millimeters each month. The earthquakes continue, sometimes dozens per week. The pressure builds in ways we're only beginning to understand. And every day people live, work, raise children, and retire in the shadow of something they've been taught to think of as dormant. The morning commute flows through Pozzuoli. Students walk to classes at the university. Families push strollers through the ancient Roman ruins that rise and fall with the earth's breathing. Fishermen cast nets in waters heated by the same forces that could, without warning, transform their world. They're not ignorant. They're not foolish. They're living the same calculated risk that millions of people make in California, in Tokyo, in Mexico City, betting that human life can coexist with geological forces beyond human control. But the bet just got more complicated. At this point, you might be thinking, if it's this dangerous, why isn't this a bigger story? Why aren't scientists screaming warnings? The answer is more nuanced than you'd expect. And intellectual honesty demands we present both sides of a genuine scientific debate. Many volcanologists urge caution against alarmism. Dr. Giuseppe De Natale, a veteran Campi Flegrei researcher, points to history. Brady-sism has happened many times over centuries without eruption. The evidence is literally carved in stone. Those Roman columns of the Temple of Serapis have been rising and falling for 2,000 years. Ancient accounts describe the ground lifting and subsiding in cycles that Roman engineers simply learned to work around. The 1982-84 crisis, dramatic as it was, produced no eruption. 40,000 people evacuated. International headlines, screaming warnings. Then nothing. The ground settled. Life returned to normal. The current unrest, while persistent, falls within the range of historical caldera breathing. Some researchers argue the hydrothermal system is simply doing what it has always done, venting pressure through earthquakes and gas release, maintaining a dynamic equilibrium that prevents catastrophic buildup. The probability of a major magmatic eruption in the next few decades, they argue, remains low. Most importantly, no one can predict when or even if an eruption will occur. The data simply isn't there for that level of certainty. Computer models can simulate scenarios, but they can't tell time. The counter-evidence, however, gives other scientists pause. Dr. Mauro Rossi at the University of Pisa emphasizes a crucial distinction. Every eruption is preceded by unrest, but not every unrest leads to eruption. We only know which is which in hindsight. What makes the current episode different is duration. This is the longest sustained uplift episode on record. Nearly 20 years of net rise with no significant reversal. Previous episodes of Brady-sism typically lasted months or a few years at most. The hydrothermal pressurization model suggests the system may be in a genuinely new state, potentially closer to some threshold we don't fully understand yet. Even if a full magmatic eruption remains unlikely, smaller phreatic explosions can happen with very little warning. These steam-driven blasts might seem minor in geological terms, but the population density transforms any event into a major disaster. The sheer number of people at risk changes the equation entirely. A phreatic explosion that would have been a footnote in 1538 becomes a regional catastrophe in 2024. And then there's the media confusion you've probably encountered. You might have seen headlines claiming supervolcano about to blow, or scientists say eruption imminent. Those are false. No reputable scientist is saying eruption is imminent. The current INGV threat level is yellow. Moderate unrest requiring close monitoring. Not orange, not red, yellow. For context, yellow means changes in activity above background levels. Red would mean eruption imminent or in progress. We're nowhere near red. This distinction matters. Sensationalist headlines erode public trust and make it harder for authorities to communicate real risks when they actually arise. Here's the crucial point. The new understanding of the hydrothermal driver doesn't necessarily make eruption more likely. It makes the system harder to read. That's a different kind of risk entirely. Magma rising toward the surface follows relatively predictable patterns. Hydrothermal pressure builds, migrates, and releases in ways that don't fit our traditional models. The absence of clear warning signs isn't reassuring. It's unsettling. We're essentially watching a system we're still learning to interpret in real time, beneath millions of people. The honest answer is that both sides are right about different things. The skeptics are right that eruption isn't imminent and may never happen. The concerned scientists are right that we're in uncharted territory with a chaotic system beneath a densely populated area. So if the science is uncertain, but the risk is real, what's the difference between a population that survives and one that doesn't? History has an answer. History has an answer, and it comes down to preparation versus wishful thinking. Italy operates one of the world's most sophisticated volcanic monitoring systems. INGV runs continuous GPS stations, seismic arrays, gas sensors, and satellite radar that track ground movement down to millimeters. The data is public. The science is world-class. There's institutional memory stretching back decades of managing volcanic crises at Vesuvius and Etna. Compare that to Guatemala, where Volcán de Fuego sits 30 kilometers from Guatemala City with minimal monitoring. Or Indonesia, where over 100 active volcanoes threaten millions with equipment that would have been cutting edge in the 1980s. Even the Cascade Range in the Pacific Northwest operates with a fraction of the resources monitoring Campi Flegrei. Italy's monitoring is exemplary. But here's the lesson that matters most. Monitoring alone doesn't save lives. Nevado del Ruiz in Colombia, 1985. Scientists detected earthquake swarms weeks before the eruption. They issued warnings. Local authorities received detailed hazard maps. The volcano gave every signal in the textbook. 23,000 people died anyway. not from lack of science, but from failure of action. Evacuation plans existed on paper, but not in practice. Authorities hesitated. Residents didn't believe the warnings. When the Lahars came rushing down at 60 kilometers per hour, there was nowhere to run. Even Pompeii had warning signs. Earthquakes shook the region for days before Vesuvius erupted in 79 AD. Pliny the Younger wrote about the tremors, the unusual behavior of animals, the unease in the air. The signs were there. They were ignored or misunderstood. The intensity of an eruption is set by nature. The death toll is set by the choices. Planning, building codes, evacuation routes, public trust, made years before the ground even starts to shake. Campi Flegrei's threat is compounded by everything that makes modern Naples vibrant. Urban density that would choke evacuation routes, aging infrastructure never built for mass exodus, and the psychological normalization of constant low-level unrest. Earthquake fatigue, the human tendency to adapt to danger until danger becomes background noise. But there's reason for hope. Italy has updated its evacuation plans extensively. The Campi Flegrei Red Zone plan includes phased evacuations keyed to escalating alert levels. Building retrofits continue. Public education campaigns run regularly. The system isn't perfect, but it's improving. The lesson for viewers elsewhere, whether you live near the San Andreas Fault, Mount Rainier, or the New Madrid seismic zone, is that preparedness is possible. It requires political will, sustained funding, and public buy-in. Commodities that are always in short supply. But the alternative is betting millions of lives on luck. Which brings us to the question you've probably been asking yourself: what can I actually do if I live there, or anywhere a threat like this exists? What you can actually do comes down to this. You can't control the Earth, but you can control your response to it. If you live in the Naples or Campi Flegrei area, preparation isn't paranoia, it's practical citizenship. Stay informed through reliable sources. INGV publishes regular bulletins at ingv.it in Italian and English. Sign up for Italian civil protection alerts. Know the current threat level and what it means. Yellow doesn't mean panic, it means awareness. Develop a household evacuation plan that doesn't rely on a single route. The A56 highway will be jammed. Identify alternative roads toward Salerno, Caserta, or inland toward Avellino. Designate a meeting point outside the Caldera zone if family members are separated. Keep a list of hotels or contacts in safe areas. Prepare a go bag for each family member. Water for 3 days, minimum. Non-perishable food. Essential medications. Copies of identification, insurance documents, property deeds. Cash. ATMs may not work. Battery-powered radio for emergency broadcasts. Dust masks for volcanic ash. Sturdy shoes and protective clothing. Strengthen your home against earthquake damage. Secure heavy furniture that could fall. Know how to shut off gas lines quickly. Keep fire extinguishers accessible. These steps protect you whether the threat comes from volcanic activity or the earthquake swarms that accompany it. Build community connections. Talk to neighbors, especially elderly residents or those with mobility limitations. Agree to check on each other if unrest escalates. In a real crisis, formal emergency services will be overwhelmed. Neighbor helping neighbor saves lives. For viewers anywhere facing geological risk, and that includes most of the American West, parts of the Southeast, and countless regions worldwide, the principles are identical. Know your local threat, earthquake fault, volcano, tsunami zone, hurricane coast, research your monitoring agencies. In the United States, that's USGS. Every country has equivalents. Practice the same preparation, go bag, evacuation plan, communication tree, insurance review. Make sure your coverage actually protects against the risks you face. Normalize preparedness as responsible adulthood, not paranoia. You insure your car. You save for retirement. You prepare for geological reality. The mindset matters most. Preparation is time spent once for peace of mind ongoing. You'll likely never need your go bag, just like you'll likely never need your fire extinguisher. But having both means you sleep better. You can't control the earth. You can't predict the day. But you can control whether you have water, a plan, and a way to get your family to safety. That difference between helpless and ready is everything. Ultimately, Campi Flegrei isn't just a story about a volcano. It's a story about how we live with uncertainty. The Earth doesn't care how many of us live above its restless forces. The disaster is written in stone in heat and time. But the death toll, the human cost, is a choice we make in the years of quiet before the noise begins. Campi Flegrei's Unrest isn't the textbook story of rising magma we can track in time. It's something stranger, a hydrothermal pressure system we're only beginning to understand. This makes it both a scientific frontier and a sobering reminder that nature still holds surprises, even beneath cities we thought we knew. No one knows if the current unrest will end quietly, as it has before, or build toward something larger. We're watching a chaotic system in real time, beneath millions of people with models that are still evolving. But because we don't know, vigilance and preparation aren't optional. They're rational. There's measured hope in this story. Human beings have learned to live alongside volcanoes for millennia. We've built great cities in their shadows: Naples, Tokyo, Seattle, Mexico City. The key is respect for the science, the risk, and the need to prepare. Tell me in the comments, have you ever visited Naples or the Campi Flegrei area? Did you even know this caldera existed beneath the city? I read every comment. If this video gave you a clearer picture of a threat most people have never heard of, subscribe so you don't miss the next one, and tap the like button to help the algorithm show this to people who need to see it. Next week, we're looking at Yellowstone's hydrothermal system, and why the threat might not be what you think.